There we go. So the first thing is find y. Yeah, exactly. So f of pi is going to be tangent of pi plus 9 cosine of
Pi.
So that's going to be, what's tangent of pi, everybody?
0.
Good job. 0. Tangent of pi is 0. It's opposite. It's sine over cosine. What's sine of pi?
0.
0. Plus 9 times, what's cosine of pi?
1.
What is it?
Negative
-1. -9. Okay, so what's the point? Pi, comma, -9. So we have the point. Now what do we need?
The slope.
Now we need the slope. We're going to find the slope by first finding the
Derivative.
derivative. So f prime of x is going to be equal to, what's the derivative of tangent? Secant, is it secant squared?
Yep.
You sure?
Yeah.
Plus 9 times what?
Negative.
Negative sine x. So we want f prime at what value? Pi. So that's going to be secant squared of pi minus 9 sine of pi. What is secant? 1 over?
Cosine.
So this is 1 over cosine squared of pi minus 9 times what? What's sine of pi? We just said it out loud.
0.
0. Again, what's cosine of pi?
-1.
-1 squared, so this thing is equal to 1. So what's the slope?
1.
That's the slope, and we have the point. So what's the equation going to be? Y plus
9.
equals 1 times
X minus pi.
pi. All done. There it is. That's all you need. You could clean that up and you could say y plus 9 is equal to x minus pi. That's fine. That's fine.
I feel so stupid when I do that out.
Derivative is positive.
When the derivative is positive, a function is decreasing when the...
Derivative is negative.
So we're really interested in finding when the derivative is equal to 0. That's what we're searching for. And can someone tell me what's the derivative of f? Someone raise their hand and tell me what is the derivative of f. Who's got it for me? Molly, what do you got?
-4 sine x
Minus 1. And we're interested in when this is equal to?
0.
So -4 sine x minus 1 is equal to 0. So 4 sine x is equal to -1/4. Right? Oh, sorry. Got it? So if you do this out, you know that x is equal to the sine inverse of -1/4. Now here's the thing. Is that a nice trig value? Just shake your head no. That is not a nice trig value. You kind of think it is because it almost looks like a half. But is 1/4 anywhere on the nice unit circle? No. So what would you have to use? So if you do this out, you have to use what? You'd have to use your... Yeah, if you use your calculator, I think you get something like -0.2... What do you get? -0.2 what? If you use your calculator on this. Can someone tell me what you get? Someone do it right. Our table's actually going to be -0.25, right? What's the next one? 3.39. And what's the next one? 6.03. And then, is there anything? Those are the 3 places, correct? Does everybody see that? Yeah. So how many regions do we have to check? We have to check 4 regions. We have to check 4 regions, everybody. Now let's just take a look at the graph here. If we just look at the original function here, what it's telling us is that the derivative is 0 here at -0.25. Here at, what is that? That's 3 point something, 03. And here, which is what? 6 point what? 3.39. Thank you. 6.03.
Yeah.
So we can actually tell just from the graph here. So we know here it's going to be positive. Here it's going to be negative, positive, and then negative. So can someone tell me where is it increasing? So if you had to answer the question, where is it increasing?
Negative infinity.
We're not. Our interval is from 2 to 7. So where are we starting at?
-2.
It actually goes 2 all the way up to -0.25. What was it?
-2.
-2. Thank you. -2. 2 point. What is it? -2.526.
2.526.
We'll do like that. Like, and it's not. It doesn't include that one, right? Because the derivative there is 0, and you union that with what? 3.39 comma 03. Why is it soft brackets and not hard brackets?
Because the derivative is 0.
The derivative is 0 at those values. Correct. The derivative is 0 at those values. So then we look at where is it decreasing? Where is it decreasing? -2, comma 2, 39, union 6.03 to 7. Right, exactly. So there's 2 ways. So hold on. We just figured out Hold on a sec. So what's the derivative of that function? Somebody raise their hand and tell me. Who's going to tell me? Someone who hasn't spoken yet today. Someone new. Hunter, what's the derivative?
1 over cosine.
Nope. What's the derivative of sine?
Cosine.
No,
Just cosine of 3t times what?
T.
Nope. Times the derivative of the inside, which is 3 minus what? 2.
I can only do a paper.
Chain rule, everybody. You have to use the chain rule right here.
Wait, why?
Because what's inside sine?
3t.
Yes, which is a separate function. Okay, so we're trying to solve this. We're trying to solve 3 cosine 3t minus 2 is equal to
0.
0. So cosine of 3t is equal to 2/3. So 3t is equal to cosine inverse of 2/3. So t is equal to 1/3 cosine inverse of 2/3. So at this point, yeah, your natural tendency, which is what you actually... So what's a good value for us to test? It's kind of hard to figure out how... Well, again, what's our derivative? Let's go look at our derivative. Our derivative is this right here. 3 cosine 3t minus 2. 3 cosine 3t minus 2. That's our derivative. What's a good value to plug into there?
0.
Sure, we can't plug in 0. 0's on the edge.
1.
Actually, you know what?
Point.
It does
1.
contain 0.
Yeah.
So we can actually plug in 0. That's a really good observation. If you plug in 0, what's cosine of 0?
Cosine of 0 is 1.
What's 3 minus 2?
1.
So this is going to be positive. And what should we plug in over here, though? Careful. You need something in terms of pi over 2. So if you do that out, what's cosine of 3 pi over 2? Cosine of 3 pi over 2? Anybody know? Cosine of 3 pi over 2.
0. Negative.
Yes, it's 0. Very good. Adjacent over hypotenuse. The adjacent is going to be 0. So this is going to be negative. So it's negative right here. So can someone tell me where is this increasing? Where is it increasing? 0 to what?
0 to 2.
0.2823. And where is it decreasing? 28. Why don't you include 2803 in any of these?
Because it's 0.
Because what is 0?
The derivative.
The derivative there is 0. Absolutely. Very good.